Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the speed of a wave using our wavelength formula that we see right here. In this problem it says a wave has a wavelength of 9.35 times 10 to the negative first meters and a frequency of 9.80 times 10 to the 8th hertz. We have to determine the speed of this wave. So in this problem here, we have a wave and we know two things about this wave. The first thing we know is that the wavelength of this wave, or lambda, is going to equal 9.35 times 10 to the negative first meters. So that is the wavelength of this wave that we see right here. What we also know about this wave is the frequency of this wave. We know that the frequency, or f, of this wave is 9.80 times 10 to the 8th hertz. And so what we have to do here is we have to use our wavelength formula to determine how fast this wave is traveling. So if we take a look right here, we have our wavelength formula, lambda equals v over f, where lambda is the wavelength of our wave, v is the speed of our wave, and f is the frequency of our wave. And in this problem here, what we're trying to figure out is v. We want to figure out the speed of this wave. So let's jump right in and take a look at how we're going to solve this problem. We know that the wavelength of a wave, or lambda, equals the speed of the wave divided by the frequency of the wave, and we're asked to figure out v. So we need to get v all by itself on one side of that equal sign. In order to do so, we're going to have to get rid of this fraction, so we need to multiply both sides by f, or by frequency. If we multiply both sides by f, f will cancel out now from the right hand side, and so the formula that we're going to use to solve our problem here will be v, or velocity, equaling frequency times wavelength. So here's the formula that we're going to use to solve our problem. We just used some algebra to figure that out, right? So velocity equals frequency times wavelength. If we take a look here, it tells us that the frequency is 9.80 times 10 to the 8th hertz. 9.80 times 10 to the 8th hertz, and a fancy way of writing hertz is s to the negative 1, and that just means that s, or seconds, here is going to be in the denominator, and you'll see why we made that simple conversion here momentarily. But hertz and s to the negative 1 are the same unit of measurement for frequency. So here's our frequency. Let's take a look now at our wavelength. Our wavelength, it tells us, is 9.35 times 10 to the negative first. 9.35 times 10 to the negative first meters. And so now we just grab our calculator and we put this in. Let's see here. We have 9.80 times 10 to the negative, 9.80 times 10 to the 8th. And we're going to multiply this by 9.35 times 10 to the negative first. And we end up with 9.16 times 10 to the 8th. What is our unit? Well, we have meters in the numerator here, meters, and s, or seconds, to the negative 1 power means that that's going to be in the denominator. So we have 9.16 times 10 to the 8th meters per second as our wave speed here. So that is how we are going to calculate and determine the wave speed of a wave when we know its wavelength and we know its frequency. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.